You have seen the damage, you have seen the system crash the data, vanish the logs, scream, but the second you turn on your flashlight to find it, it vanishes. In the 1980s, the radiation machine called the Thirac 25 began delivering lethal doses to patients. It wasn't a broken hardware switch, it was a ghost in the code, a split second timing error, a race condition that only appeared when other operators type at a specific speed. This is the Heisenbug. It's the most dangerous defect in parallel computing because it refuses to be seen. A normal bug is a rock, it stays where you put it. A Heisenberg is a shadow named after the Heisenberg uncertainty principle. This bug changes its behavior the moment you try to observe it. You think you are being smart by adding a print statement or attaching a debugger. Congratulations, you just fixed a bug, or rather, you hid it. You are no longer looking at the real system, you are looking at a version that has been slowed down by your own curiosity. The science is altered by why is this happening because your code has lost its integrity. Parallel computing is like 1,000 people trying to write in the same notebook at once. If you don't have a strict system of trust and order, you get a think about the ABA, a problem thread A reads a value of 1. Thread B sneaks in, changes it to 2, then swaps it back to 1 in a microsecond. Thread A looks back and thinks all good, nothing changed, but it did change. The system is operating on an illusion. When your threads start lying to each other about the state of the memory, the entire architecture is built on sand, is just a headache for developers. Look at Knight Capital Group, August 1, 2012. A threading deployment error woke up zombie code in their high frequency trading system. For 45 minutes, their servers were trapped in a loop of bad decisions. They lost $10 million per minute. Why didn't their test catch it? Because the bug was covered in the quite slow environment of a test server. It stayed hidden. It only came out in high pressure, high speed reality of the live market promise, a promise that the data is real, the state is consistent, and the system is honest. When we ignore, you don't use a magnifying glass, you use stress. You have to be a steward of your hardware. You don't just write code, you manage resources that don't belong to you. You use first testing to bombard the system with chaos until the bug is forced to show its face. You record and replay to capture the execution truth without interfering with the speed. You use atomic operations to ensure that when a change happens, it happens all at once or not at all. No half truths, no illusions. Every line of code system is honest. When we ignore thread safety, we are being reckless with the power we have been given. Don't build systems that only work most of the time. Build for the truth, because in a world of Heisenbergs, the only thing that survives is integrity. Stay sharp, Hunt.